Hello, this is Ryan from High Desert Math Tutor, and today I want to talk to you about the slight differences between solving equations and solving inequalities. So, for the most part, there's no difference between solving equations and solving inequalities in terms of the steps you follow when isolating the variable x. So here, I'm going to give you two examples. One example with an equation and an inequality where there's literally no difference in the steps you follow when solving the inequality versus the equation. And then I'm going to give you an example where there is one different step. So everything is the same except for one difference in the process. So right off the bat, you see here, this equation is a prime example where there's one single x. All the x's are combined on one side of the equation. All we have to do is get x by itself. So when you get to this point in solving equations, as always, we want to start by getting rid of any addition or subtraction. So here we will undo adding 5 by subtracting 5 from the left side. But whatever you do to the left side of the equation, you have to do to the right side of the equation. What we have left over on the left side is 3x. We'll bring down our equal sign, and then 14 minus 5 is 9. Next, we get rid of any multiplication or division happening to x. So we're multiplying by 3. So to undo that, we will divide by 3. Whatever you do to the left side, we will do to the right side. Goodbye. And finally, we see x is 3. So this is the x value that will make the left side of the equation the same as the right side of the equation. And if you want a quick demonstration of how to check, let's do it. So we will take our equation over here, 3x plus 5, but instead of x, we're going to substitute x with 3. So we see now, if we multiply, 3 times 3 is 9, plus 5, and 9 plus 5 is 14, which is exactly what we wanted this to be equal to, or to be the same as. So normal algebra process, normal algebra steps. So here, let's just take a quick look at how things vary over here. So as normal, we're just going to subtract 5 from the left side, subtract 5 from the right side. All we have left over on the left side is 3x, but instead of bringing down an equal sign, we are going to bring down this less than symbol. And now 14 minus 5 is 9. Since we are multiplying x by 3, we're going to undo that by dividing by 3. But whatever you do to the left side, you do to the right side of the inequality. Cancel these 3's. And our final answer is to make this inequality true, x has to be less than 3 in order for 3x plus 5 to be less than 14. So this is telling us to make this inequality true, where this side is less than the number 14, x could be any number as long as that number is smaller than 3. But you see, in terms of the algebra, there's no difference in this algebra problem with an equation versus this algebra problem with the inequality. Now, where the difference arises between solving equations and solving inequalities is whenever you have to multiply or divide by a negative number. So that's one instance where you'll see a difference between equations and inequalities. That's what we're going to see here today. But just for future reference, there's one other instance where you'll see something that is different when solving equations versus solving inequalities, which that arises when you take the reciprocal of each side of the equation, or the inequality, sorry. But again, we're not going to see that today. So here, I just want to show you where the difference arises. So when we solve this equation, there's literally no difference between solving this equation and the one we just did above. First, we get rid of any addition or subtraction by subtracting 1. If you subtract 1 from the left side of the equation, you have to subtract 1 from the right side. All that's left over on the left side is negative 5x. We will bring down our equal sign, and then negative 39 minus 1 is going to be negative 40. We are currently multiplying x by negative 5, so the opposite of multiplying by negative 5 is dividing by negative 5. You do it to one side of the equation, you do it to the other. Goodbye. Our final answer here is x is equal to positive 8. So negative divided by negative is positive. Now, this last step is where we're going to see something change over here. So solving our inequality, we will get rid of any addition or subtraction first, whatever's happening to x. We subtract 1 from the left side of the inequality. We have to subtract 1 from the right side. These cancel. We bring down the negative 5x. We bring down the inequality. Negative 39 minus 1 is negative 40. But here is where something changes. When you multiply or divide by a negative, not what's currently happening here, but what we are about to do, we need to divide by negative 5 to get this negative 5 to cancel. But when you multiply or divide by negative numbers, the big change here is our inequality has to change direction. So it was opening to the left, now it has to open to the right. Other than that difference, we just bring down the x, we bring down our answer, negative 40 divided by negative 5 is positive 8. And there's our final answer for this inequality. Now, I don't want to get into playing with the numbers in this instance for you to see that this is justified, that the inequality changes direction. I just wanted to highlight the difference for you in this video so that it's clear that there's no difference between solving equations versus solving inequalities other than when you multiply or divide by a negative number. And as I mentioned before, also when you take the reciprocal of each side of the inequality. Those two situations are what cause the inequality symbol to change direction in the middle of your problem. So if it's not for one of those two operations happening, there's no difference between solving equations and inequalities.